Module 3, Lesson 2, the Pandas package. So, the Pandas package is used mainly for manipulation of data and data analysis. And in fact, the name Pandas stands for panel data, and the basic building blocks for the Pandas package are 1. The series object. The series object is simply one-dimensional labeled array. Unlike the numbers array, which had no labels, the series object is going to have these labels here, 0, 1, 2, 3, 4. We'll see more in code. The second building block for the Pandas package is the data frame object. And the data frame object is simply a two-dimensional labeled data structure. That is, it has the rows like so, and it also has the columns with titles. Now let us dive in and see how to work with the Pandas package and also understand better how to work with this package. Unlike the NumPy, whereby you are working mostly with arrays, in Pandas we'll be working majorly with two data structures, and that is the Pandas series and the Pandas data frame. These two data structures are very important when working with data in data science, since many a times data in a data science project comes in form of a CSV, a text file, .data, or even Excel file. And this data, in order to be used in your project, has to be converted to what we call data frame or a series so that you can work with it. By this I mean Pandas becomes so important during this conversion. That is why you have to learn the basic data structures of Pandas. And so, as I've said, it has two data structures, and that is series, which is the most basic, then data frame, which is kind of advanced. So let us start with a series. So the way you create a series, let me first import, as usual, just do like this: import pandas as pd. Simple as that. And then you run your code. Then down here, let us create series 1, which will be pd. I'm now using this Pandas package that I've been imported and gave it an alias, in this case pd dot is called series, just as simple as this. And again, you passed a list inside this series, and in this case I'll pass a list of numbers 10, 20, 30, 40 and 50. And let me just print the series down here so that you can see what I mean when I say it has labels. You see, when you print the series down here, you can see now it has a label of 0, 1, 2, 3, 4 and the numbers which I've inputted in that series. Now suppose you might be thinking, how can I change these labels for this series? Maybe you want to put your label to be 1, maybe A, B, C, D, like so. And the way you can do this is very simple. Let me just create a series 2 here again and say pd.series, and then let me just pass my numbers here. In this case, let me say 20, 70, 80, 90 and 100. And so to input your own labels for these indexes, you just write index like so, then equal sign, and then the square bracket, and then inside here you pass the strings. I hope you can remember the string they are put in quote. You put them in quote. In this case it is A, let us say B, let us say C, let us say D, and lastly let us say E. It is as simple as this. So this A, B, C, D and E, this A will be attached to this number 60, this B will be attached to this 70, C 80, D 90, and E ultimately will be associated with 100. And so again, if I print my series down here as 2, this guy, and if I run this code, boom, there you have it. A 60, B 70, C 80, D 90, E 100. And that is the way you create your own indexes for a particular series. One key thing I want to remind you, when you come to Pandas package, we have series, and this series, the only difference between series and NumPy arrays is that they have labels or indexes associated with them. I know now you might be thinking that this is the best way to create series with labels, but just to surprise you, this might be the worst or even next to the worst method ever of creating a series. There is another cool way in which you can create a series without really straining, and this is the way you can do it. This is S3 that I've created. And now, if you can remember, while we are working with data structures in Python, we learned what we called dictionaries, and dictionaries have key value pairs. So instead of doing this, I don't know what is this, instead of doing this, this thing here, the only thing you can do here is create a data structure in form of a dictionary and pass a key and its value pair. And this is what I'm talking about. A, just do like this, it has 10, comma, B, it has 20, comma, C, it has 30, comma, D, it has 40, and lastly let us say E has 50. Now again, if I print my series down here as 3 and we run this cool code, boom, again here now we have the same kind of structures, but now in one code you just need to pass in a dictionary. This is more effective as compared to this guy here. So much wasting of space and code. Just have to write one piece of code and all thing is done. Now one key thing I want you to note when using this method is that this key of this dictionary that you have just passed inside here becomes the index of your values in this series. So we have A10. This is the index A with value 10, like so. Now with series you can perform the same function that you performed on a list, that is slicing. For example, this is S3, and so if I want to access this guy here, this is at the index, this is 0, 1, 2. I can just do something like that, and if I run this code, you see it prints 30. And again I can access the same guy with something very cool using now the key of this guy, which is C, and if I run this code again, you see it prints 30. So the next thing I want us to look at data frames, and the way you create a data frame, very easy. So let us say D1 just to label our data frame, and you just say PD dot, now you'll use what we call data frame, like so. Then as usual do like this, but instead now here we'll pass a dictionary, but now the key will be the name that defines the title of that column, and the values of that dictionary will be a list of values. This is what I mean. For example, I have names here, and then the value now will be defined by the names of the pupils who did the exam. For example, let's say Kevin and Mai. Then we have this guy by the name Thomas. Then we have this guy by the name Brian. Then we have this guy by the name, let's say Peter. This is the first column. Now you want to define a corresponding column that defines their marks. In this case, I'll just put a comma and just then again now I'll say marks. The values will be corresponding marks to these names. As you can notice, the value of this data frame, now I'm passing a list which corresponds to the key of this data frame, or rather of the dictionary which is in this data frame. And now let us say Kevin did so badly, he got maybe 40%, and there is the guy by the name Thomas who is so lazy, he got 20, and now Brian is particularly lazy than Thomas, he got 30, and Peter is the worst of all, he got 5%. Surely, how can someone in the world get 5%? That is terrible. So now this is the way you create a data frame. And so if I print my data frame down here, you actually see, wonderful. Now you have this kind of a table with two titles, or rather two headings. That is the name, and it corresponds to the value parameter for this particular dictionary. That is the name. It corresponds to the values in this list, that is Kevin, Amai, Thomas, Brian, Peter. The second parameter in this dictionary is this key value pair. In this case it is marks, and the values are 40, 20, 10, 5, which are passed in a list. So that is the basic way you create a data frame in Python. So the last thing I want us to consider in this lesson is how to work with CSV file. As you have noticed, we have been using just normal data, or rather very simple data, which is not real world data. And this cannot be of much use when it comes to a real world project. So let us get our hands dirty and see how we can work with the real world data. So before you move on with this lesson, I want you to go to the resource section. There is a file I've put there. It is known as the iris dataset Excel file. Copy it and come and paste it inside your project like so. Here it is, iris dataset. After you have done that, you are good to come back and continue with this lesson. So the first thing you want to do is to import this CSV file into your code. And the way you do it, you just write simply, you give it the name, which is, let us say, iris dataset, and then use the pandas package, which will be pd dot, and now use this method by the name read CSV. You pass your name of your file inside there, which is iris underscore dataset dot CSV. As simple as that. Once you have done that, just run your code, and now your file has been imported into this code, or rather into this project. So the first thing you want to do is to check the first 5 records of your data. That is, the only thing you are required to do is to do this, iris dataset dot head. This checks if your data has been loaded, and to confirm that, it loads the first 5 records of your data. And so if I run my data here, you can see it prints some interesting things. And in this case, my data is a list of flower names of different species. I don't know, iris, setosa, etc. And now we have the species here. We have the sepal length, the sepal width, the petal length, and the petal width. These are the attributes of these flowers that I've loaded here. And you can see they have some data here, 5.1, 3.5, 1.4, and so. So once you've done this, the second thing you want to do is to check also the last 5 records to ensure that your data has been loaded fully. And the way you do this, you just say iris underscore dataset dot, instead of head you say tail. And if you run your code, you see it will load the last 5 records. And in this case, I can see the species are iris virginica. They are the last 5 records. And so one more thing I want you to see is that this head function, you can manipulate it to suit your needs. For example, let us say I want to fetch the first 10 records. I only pass here the number 10. And now if I run this code, you see it loads the first 10 records starting from 0. And even so, I can do the same thing with the tail function. If I want to load the last 10 records, I can just pass in 10. And if I run it, you can see it runs and prints the last 10 records. Now, the next thing I want us to see is how to fetch different columns of this dataset. Suppose I want to get the column species and the column sepal length. The thing I can do, I can just say iris underscore dataset dot iloc. This iloc represents, or rather means, index location, and then square bracket. And now let us say I want to fetch the first 5 records, that is 0, 1, 2, 3 up to 4. I can do something like this: 0 and then full colon 4, the same way you did slicing. And now this first parameter here, 0 full colon 4, represents this number of records that you want to fetch. This one here, this is a record up to the petal width. This is one record, this second record, this another record, this another record. By me saying 0 full colon 4, I mean the first 4 rows. Hope you have understood. And now what I want to fetch is the species and the sepal length. So what I'll do 0 full colon, instead of 1, as you can remember, using our slicing function, I will write 2 so that it can fetch 0, 1. The same here, I want to fetch up to 4, so I write 0, 5. As simple as that. And if I run this code, now we have some very interesting thing. You see now here it fetches up to 4, 0, 1, 2, 3, 4. And again here it fetches the species and the sepal length. Now it has fetched the first 5 record, and it has fetched the 2 columns, which is species and sepal length. Again, if I want to fetch petal length and the petal width, this is 0, 1, 2, 3, 4. So it is between 3 and 4. So what I will do is iris underscore dataset dot ilog, and then now I want to fetch the first 5 record, that will be 0 full colon 5, and it is 0, 1, 2, 0, 1, 2, 3, 4. It is the third and the fourth column. In this case I will do 3 full colon, instead of 4 I will do like that 5, so that it can fetch 3 and the fourth one. And so if I run my code, you see it fetches the petal length and the petal width and the first 5 record. Now you can play around with this code. You can utilize the slicing function to suit your needs. For example, let me just copy this guy down here. If I copy this guy down here, let us say I want to fetch all the columns. You remember when I write this, it means start from the first column, go up to the end. So if I do something like that and run this code, you see it prints all the columns in this data set. And if I do something like this, let us say I want to fetch all the columns and all the rows. Let me just copy again this guy here and paste this guy down here. So I'll just put 0, 0 like that, and I'll run this code. And so this will print everything. This here, it means it has printed everything, but it is trying to utilize space, so you cannot see all the rows, or rather let me say all the records. So the next thing I want us to look is how to use the log function. We have seen how to use the ilog. The log function is nearly the same with the ilog function, but it has just a little difference as compared to the ilog function. And the way you use it, let us say iris underscore dataset. This is our dataset. So now the first argument is the same as the ilog function, and let us suppose you want to fetch the first 5 records. That will be 0 full colon 4 comma. But now you can, with the log method, you can specify the exact name of the, or rather the title of the column of which you want to utilize. In this case, let us say I want to fetch the sepal length, and also you put comma. Let us say this other guy is sepal width. And so this iris underscore dataset dot log, then the square bracket, the first parameter is the same as the ilog method, which is the range of the rows that you want to fetch. In this case, I want to fetch the first 5 rows, so I'll put 0 full colon 5. And then now something cool with the log function is that you can specify the exact name of the columns in this second parameter using these curved braces. And that is the way you can do it. Now The last thing I want us to consider when working with pandas, or rather data frames, is how to fetch certain record with certain condition. For example, assuming I want to fetch only the flowers with sepal length which is greater than 5. How can I do this? I can just write, for example, let me just write at first iris underscore dataset, and in this case I need the sepal length, but in this case I need it to be greater than 5. If you run this code, you see number 1, it prints something interesting here. True, false, true, false. This true means that in this record 1, that the sepal length is greater than 5. And so if I wish to print these records that have the sepal length greater than 5, I only require to have this guy outside this iris underscore dataset like so, and pass this condition inside this guy. And so if I run this code, it prints the record whose sepal length are greater than 5. If you look carefully, you see 0, 5.1, 5.4, 5.4, 5.8, like so. And so let us say you want to print the sepal width which is greater than 3, and in this case what I will do, just do something like that. Sepal width is greater than 3, and so if I run my code again, sepal width will be 3.5, 3.2, which is greater than 3. And so I can do a lot of cooler things in here. Let us say I want to add more than 3 conditions. As you can remember, using our AND function which evaluates more than 2 conditions, and if these 2 conditions evaluate to true, then it is the only time this code will be executed. And so by this case, I want the sepal length to be greater than 5 and the sepal width to be greater than 3. If this condition inside here is satisfied, then I need to print those records. If I run this code now, you can see the record which have been printed here have the sepal length. If you look closely, all of them are greater than 5, and if you look at the sepal width, all of them are greater than 3. And so that is the way you can fetch certain record specifying a condition. So I hope you have understood using this package Pandas. It is so important. I've included a couple of resources, so many resources that can help you to understand deeply and even greater function that you can perform with this Pandas package. Now you are ready to go to our next package, which is the Matplotlib. This is the package that is used for sketching graphs, and so it's a cool package. Let us meet there.